Show that the derivative of cosecant inverse of x is negative 1 over x times the square root of x squared minus 1. First, we let y be cosecant inverse of x. What remains to show is that y prime is 1 over x times the square root of x squared minus 1 with the negative 1 in the numerator. Once we set y be cosecant inverse of x, we can rewrite it. This is not the derivative, but the rewritten of the function. Cosecant of y equals x, and then we differentiate with respect to x implicitly on the left-hand side. But first, because of the inverse, we have to first restrict the domain of cosecant inverse. For cosecant, we would have to restrict the domain to the first and the fourth quadrant only. We cannot use 0 though. We can use negative pi over 2 and pi over 2. And so the domain of cosecant, so that the function cosecant is 1 to 1, is negative pi over 2 to 0, and then 0 to pi over 2. We differentiate the equation implicitly, the left and the right. Technically, only the left-hand side is implicit. The derivative of cosecant is negative cosecant cotangent, and we still put y inside these. We never evaluate the derivative at the derivative, and so the input of the derivative is still y, but this derivative is with respect to x, and so we would have to multiply dy dx or y prime. On the right hand side, the derivative of x with respect to x is 1, and so we end up with dy dx, which is y prime, equals 1 over negative cosecant of y times cotangent of y, which is negative 1 over cosecant of y cotangent of y. And this is the derivative of cosecant inverse of x. But we can't leave the answer in terms of y. Using the trig identities or the right triangle to figure out what cosecant of y and cotangent of y is, we draw a generic right triangle and label one of the angles that is not a right angle y, because cosecant of y is x. Since cosecant of y is x, and x can be rewritten at x over 1, cosecant is the reciprocal of sine, so sine of x is 1 over x. And sine is the opposite over the hypotenuse, and so we would label the opposite side to y as 1 and the hypotenuse at x. The missing side is therefore, using the Pythagorean theorem, it is the hypotenuse squared minus the remaining side squared, and then the square root, because we're looking for the length. By looking at this right triangle, we see that cosecant of y is, well, cosecant is the reciprocal of sine, and so if sine is opposite over hypotenuse, then cosecant is the hypotenuse over the opposite, but the hypotenuse is x and the opposite is 1. Similarly, cotangent of y is the reciprocal of tangent, but tangent is opposite over adjacent, so cotangent is adjacent over opposite. The adjacent in this case is the square root of x squared minus 1, and the opposite is 1. And so we can rewrite y prime as negative 1 over cosecant of y is x over 1 or x. Cotangent of y is the square root of x squared minus 1. And this shows that the derivative of cosecant inverse of x is negative 1 over x times the square root of x squared minus 1. We got away with the plus or minus because we use the right triangle. If we were to use the identity to come up with these expressions, then we would need to keep in mind of the restricted domain for this to work, because at some point we need to take the square root, and notice that we got rid of the negative square root. In this case, it makes sense because it is the side of the right triangle, but if we were to use the identity, we will need to justify why we do not use the negative square root.